Okay, let's continue on with the Chapter 1 review, starting with problem 28. Asks us to find the vertical asymptotes of this function. So you have a vertical asymptote when the denominator equals 0. So this is algebra 1 time, isn't it? X squared minus 9x plus 14 equals 0. You can solve that hopefully by factoring. If not, you would have to pull out your quadratic formula. Let's try factoring. If you don't remember how to factor, one way you can do it is the x method, where the top of the x is a times c. That's 14. Bottom of the x is b. That's negative 9. You want numbers here that multiply to be the top and add to be the bottom. So let's use negative 7 and negative 2. Now, if your coefficient is 1, you do the x and you're done. Okay, so if you have a 1 here, do the x and you're done. So that gives us our factors: x minus 7, x minus 2 equals 0. And that means if either one of these elements is 0, we'll get 0. So that means if x is 7, this would be 0. If x is 2, this would be 0. So we found the things that make our denominator 0, but are we done? We're not. Because if we get 0 over 0, then we have a hole in the graph. And in fact, you can see if you plug in 2 to the numerator, you would get 0 over 0. So x equals 2 is not a vertical asymptote, it's a hole. X minus 7, x equals 7 is your vertical asymptote. And by the way, that's the correct answer. You say x equals 7. So when they ask you to find a vertical asymptote, the answer should be in that form. Okay, 29. 29 wants us to find some horizontal asymptotes. And again, for this series, I'm going to let you look at your own worksheet. Finding the horizontal asymptote is always asking the same thing as what are the limits as x approaches infinity, and what is the limit as x approaches negative infinity. Okay, that's why when you were in Algebra 2 and maybe even pre-calculus, they started talking about horizontal asymptotes, but you never really got to find them. The reason was because they require limits. So let's look at letter A, and again we're looking for the dominant x, and you find that by who has the highest exponent. In this case, tie game, we have 2x squared over x squared. The numerator and the denominator have an x squared, so that means the limit as x approaches infinity is going to get closer and closer to 2x squared over x squared. In effect, the x squares kind of cancel, so you have to look at your leading coefficients, which would be 2 over 1. So the asymptote here would be 2, and actually I shouldn't even put an equal sign here. The horizontal asymptote would be y equals 2. Okay, so that means as your graph gets really big, that you are going to be heading towards y equals 2, and you're going to get stuck there. Now, is it going to be different for negative infinity? Actually, I think this should have come that way. So is this going to be different for negative infinity? Not at all, because these are both squared, so you're going to end up with positive numbers, so it's still y equals 2. It's only one vertical asymptote. Okay, let's look at letter B. We have a 3x to the 5th on top and an x to the 4th on the bottom. Those are your highest exponents, so the top dominates. So what happens as x goes towards infinity? Well, the top gets bigger and bigger, and it's getting bigger faster than the bottom. So this function is just going to keep growing and growing and growing. That means there is no horizontal asymptote as you go towards infinity. This function will actually just keep getting bigger. Nothing's going to stop it. What about if you go towards negative infinity? Well, we're going to have a negative on top, a very big negative number. We're going to have a very big positive number on the bottom, but the top's always going to be bigger. So actually what's going to happen is we're going to go towards negative infinity, over here. So again, there's no horizontal asymptote. This is going to get more and more negative. This is going to get more and more positive. But there's no number. So we would write no asymptotes, no horizontal asymptotes. Okay, let's look at letter C. As x approaches infinity here, our dominant is this x to the 5th in the denominator. So if your denominator dominates, you're going towards 0. Think of like 1/10 of a pizza, 1/100th of a pizza, 1/1000th of a pizza. That would be a bad deal. 1/1,000,000th of a pizza, right? As your denominator gets bigger, your number gets smaller and smaller and smaller. So this is actually going towards 0. So if we did it as a limit as x approaches infinity of f of x equals 0, that's a horizontal asymptote because 0 is a number. What about negative infinity? It's still going towards 0. Even though this is going to be a negative number, it's still always going to be creeping up towards 0. It's just going to be coming from underneath. So in this graph, you actually have this negative, you're going towards 0, but you're coming from the negative side. So actually, the horizontal asymptote in letter C is y equals 0. So that's how you would write it. So sorry, I'm kind of out of room there. So for letter C, there's a horizontal asymptote at y equals 0. And it's the same positive or negative, so there's really only one asymptote. Okay, 31. Why is this function discontinuous at x equals -1? You can see there's a hole in the graph and there's a function value in a different place. So it's tempting to just write that. There's a hole in the graph and a transporter beam. But of course we want to write in calculus language. So let's write the real reason that's discontinuous. A hole in the graph sometimes means that, let's see, this is called f of x. F of x doesn't have a value, but it actually does have a value. So f of -1 actually exists. It's 2. Well, what else can make something discontinuous? It can be discontinuous if the limit doesn't exist. Well, actually, the limit as you approach -1 exists. So that's not the reason. So what's the third possible reason? That is, the limit does not equal the function value. So the answer to number 30 would be, you could write the limit as x approaches -1 of f of x equals -1, because that's the y value there. F of -1 equals 2, right? That's where the transporter beam is. So the actual value of that is 2. So therefore, the limit of f of x as x approaches -1 does not equal f of -1. That's the reason for the discontinuity. Okay? It's kind of nice to show that you figured out the limit and you figured out the value and then make the statement that they don't agree. 31. Why is this function discontinuous at x equals 7? Probably has something to do with the vertical asymptote. So how can we write that in calculus language? We can say the limit as x approaches 7 of q of x does not exist. And you could put comma infinity if you'd like. Right, you could also actually say that q of 7 is undefined. That's also a reason why something would be discontinuous. So either one of those would work, because it only takes one thing to ruin continuity. 32. Discuss the continuity of this function. So when the question asks you to discuss continuity, it wants you to say the domain of the function. So for what x values does this function have a value? Well, the only time it wouldn't have a value, and the value would be undefined, would be if you had a 0 in the denominator. The only time we're going to have a 0 in the denominator is when x equals 7, right? We don't really have to do any math to see it. We can just see that. So we can say that h of x is continuous for the intervals negative infinity is less than x is less than 7 and 7 is less than x is less than infinity. You can also write that in interval notation as negative infinity 7 union 7 infinity. So that's the first thing to discuss. Now, when you're discussing continuity, you also need to discuss that uncomfortable issue of where it is not continuous. You would say h of x is not continuous for x equals 7 because h of 7 is undefined. That is a complete discussion of the continuity of this function.